This video tutorial is for PSD 305. Our level 2 question is going to be to understand the probability of a complement of an event. So what we're working with today is really something I think you're going to like, probability. This is the entire lesson is going to be all about probability. This is something that I think is pretty intuitive for you. You probably have a good idea about what probability already means, even though you might not have answered math questions in regards to a probability problem. However, it's a really intuitive skill, and I think you're going to like it because it's something that you can use in the real world as well. So we're going to be finding the probability of an event and its complement. So it's the level 3 question here. And then finally, extension skill would be to determine the probability of a simple event. So let's get started. Just to kind of give you an idea of what we're going to be talking about today with probability, I have here the box of, or like a picture of a box of a Frito-Lay Classic Mix. So here we've got all the different types of options that we could see within this Classic Mix box. So the first question says you reach into the box and what is the probability of randomly selecting a bag of Fritos? So let's say you reach into this box, you're not looking specifically for anything, you're just grabbing the first bag that comes to your hand, and what would be the probability that that bag would be Fritos? Well, when we set up a probability, it's going to be a ratio, and we're going to put on the top here the possible number, the total number of Fritos. So we're going to look at the number of Frito bags over the total number of bags. So in this case, there are 4 possible Frito bags, right? Over here we've got a total of 4 possible Frito bags, and the total number of bags in this entire box is 20. So in other words, if we were to reduce this fraction, I would get 1/5. Okay, the probability that I will reach in and randomly grab a bag of Fritos is 1 out of 5. So I have a 1 in 5 chance of grabbing a bag of Fritos than in anything other, in any of the other options. So I have a 1 in 5 chance of grabbing a bag of Fritos. Now the next question says, what is the probability of not selecting a bag of Cheetos? So this time I'm going to look at not selecting Cheetos. So that means I want to eliminate the Cheetos option. Okay, so if I eliminate the Cheetos option, remember there are 20 total possibilities, and I'm not wanting to select Cheetos. So I'm going to subtract 4 because there are 4 Cheeto bags, and I would get 16. So now I take the fact that I have 16 possible bags that I can choose from over the total number of possible bags, which was 20. And if I reduce this, I end up with 4/5. So I have a 4 out of 5 chance, okay, of selecting something that is not a Cheetos bag. So that's the basis of probability. So let's start by defining a probability. So we're going to get, into some more math stuff here. But basically all that a probability is, and you saw that above, is a numerical measure. So we had a fraction. It's a numerical measure of how likely something is to happen. Probability can be expressed as a ratio, which is what we showed above. 4 out of 5 is a ratio. It can be expressed as a percentage, or you can express it as a decimal. Now, if something can never happen, the probability will be 0. Now, if something will, or it should be a slash here, is certain to happen, then the probability is 1 or 100%. Okay, so we use 0 or 1. So if something never happens, the probability is 0. If it will always happen, the probability is 1. Okay, it's a fraction. Like in our above example, when it was 1 out of 5, if it would always happen, then it would be 5 out of 5, or equal to just 1. All right, now last, as a ratio, probability can be expressed as the number of possible outcomes that result in your event. Let me move this over here. You're going to have to copy this down, so I'm going to go a little slower. So it's the number of possible outcomes. There shouldn't be an of here, sorry. Number of possible outcomes that result in the event over the total possible outcomes. Total possible number of outcomes. So above, just to kind of tie that back to the last example that we showed, we had the total number of Fritos options. That was the event. The event was picking Fritos. So that had a possible 4 outcomes. And the total possible number of outcomes was the total number of chips in that box. Okay, so that was why we did 4 over 20 to get 1 out of 5. So a probability can be written in words as this. So please pause the video and copy that down. It's kind of a lot, but that's all you're doing is finding the number of possible outcomes and dividing that by the total possible of outcomes. So next we're going to go over some basic probability problems. With coins, you're going to see this often throughout this unit. You can either have heads or tails. So what would be the probability of a heads occurring? Well, that's 1 out of 2, right? Either you're going to get heads or tails, so it's 1 out of 2, where 1 is the event that you want, so the event is getting tails, or I'm sorry, heads in this case, over the total number of possibilities, which was 2 options, heads or tails. So that's why it's 1 out of 2. And we can write that as a percentage. That would be 50%. Or we can write that as a decimal as 0.5. Now for dice, how many sides are there on one die? There are 6 sides on a die. So just like those normal dice that you would roll in a game where you have, dice that look like this. So I already kind of drew on a couple of these, but the numbers on the sides of one die are numbers 1 through 6. Okay, there are 6 sides, and each side has a different number, 1 through 6 on there. So this first question says, what is the probability of rolling a prime number? So let's think about what prime numbers are. Remember, a number that is not divisible by any other number other than itself and 1 is a prime number. So the prime numbers, if you pick through all of these, I'm going to list all of our possibilities here, 1 through 6. 1 is a prime number, 2 is also a prime number, 3 is a prime number, but 4 is not. 4 is divisible by 2, so it's not a prime number. The number 5 is also a prime number because it's only divisible by 5 or 1. And number 6 is also not a prime number. It's like 4 because it's divisible by a 3 or a 2 and 6 and 1. So here are my prime numbers. Okay, so the probability of rolling a prime number is going to be the fraction or the ratio of showing the prime number options. So there's 1, 2, 3, 4 possibilities for picking a prime number, and the total number would be 6. Okay, because there are 6 options on that die. You can roll anything from a 1 through a 6. So the probability here, if I reduce that fraction, is 2/3. So I have a 2 out of 3 chance of rolling a prime number when I roll a die. Now the next question says, what is the probability of not rolling a prime number? So this is the example of seeing an event and that event's complement. So the event of rolling a prime, so my event would be a prime number. The complement of that would be rolling something that is not prime. And in this case, remember there are only 2 options for not rolling a prime, and that was 4 or 6. So that's 2 out of 6, which is going to simplify to 1/3. Now if you take a look at those numbers, 2/3 and 1/3, notice that it's just the difference between 1, the number 1, and that event. So 1 minus 2/3 is the same as 3/3 minus 2/3, which is 1/3. So you can do that a number of different ways. If you already know the probability of the event, you can just subtract simply from 1 to find the event or its complement. Or you could just redo the same probability and set it up like we did here. Now, when you work with cards, you got to know a couple basic facts. There are 52 cards in a standard deck, and there are 4 suits in a deck. With a deck of cards, you've got the hearts, you've got spades. Let's see if I can remember how to draw a spade. Nope, pretty bad, sorry. Well, you've got diamonds, and you've got clubs. See, the clubs kind of looks like that. It's pretty bad, sorry. So there's a spade, kind of. So those are your options, the 4 different suits. And for the suits and their colors, you've got diamonds, and that's red. You've got hearts, which is also red. You've got clubs, and those are black. And you've got spades, which are also black. Now in each suit, there are 13 cards, okay, for a total of 52. If we took 52, divided it by 4, we would get 13. So each suit has 13 cards. Now in each suit, there is an ace, 2 through 10 actually, so 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you have other face cards. So an ace is considered a face card, but face cards Jack, Queen, and King. So there's a total of 13 cards. Okay. Now I'm sure you've already played cards before and seen that, but I just wanted to go through all this information with you because now we're going to do basic probabilities using cards. So the first one, what is the probability of selecting a club? Now remember, there are 13 clubs out of a total of 52 cards. Okay, so the probability here is going to be the event that I pick a club. There are 13 possible clubs, so there are 13 outcomes for selecting a club over the total number of clubs, which is, or I'm sorry, a total number of cards, which is 52, and that gives me 1 out of 4 when I reduce that. So I have a 1 in 4 chance of selecting a card that is a club. Now the probability of selecting a king, we have to think about all of the possibilities of kings. There is a king of clubs, there is a king of hearts, there is a king of diamonds, and there is a king of spades. So that means there are only, this time, 4 possible king cards out of a total number of cards, which is 52. Okay, so here we have 4 out of 52, and that probability is much smaller. This is 1/13. So I have a 1 in 13 chance of selecting a king. Now the probability of selecting a red ace, let's think about all of the possible red aces. I have an ace of hearts, and I have an ace of diamonds. These are the only red suits. So that means I have 2 cards out of a possible 52 total cards. That would be an ace, a red ace. So that's 1 out of 26. So I have a 1 in 26 chance of selecting a red card that is an ace. Now the probability of not selecting a 4 or a 7 means that I can select any other card other than a 4 or a 7. So what I'm going to do here first, it's just kind of weird, I'm going to first do the probability of selecting a 4 or a 7. Okay, so I'm going to add the two probabilities together. And then I'm going to take the complement of that, which would be not selecting a 4 or a 7. So let's show you what I mean. Okay, so the probability of selecting a 4. Now, in the 4 different types of suits, there are 4 4s. Okay, there are a total of 4 4s in the deck. And for a 7, there are a total of 4 7s in the deck. Okay, which means that I have a possibility 8 possible outcomes result in a 4 or a 7 out of a total of 52. That means that not selecting one of these 2 cards, if I take 52 minus 8, I have 44 cards. Okay, so there are 44 cards out of the 52 cards that would not be a 4 or a 7. So that's the complement here of the event of picking a 4 or a 7. So not selecting a 4 or a 7 would be a 44 out of 52 possible chance. And I'm going to reduce this. Okay, think about numbers that fit into 44 and 52. Obviously 2 does. It's an even number, but we can also reduce it by another factor of 2, which means that I can reduce this all by 4 to get 11 over 26. I can also put that into my calculator. I'm sorry, not over 26, out of 13. I can also put that in my calculator too and do math enter enter when I reduce that fraction to get a reduced fraction of 11/13. So there's 11 out of 13 chance of not selecting a 4 or a 7. Alright, now that's the end of the lesson. Please show me the note sheet, and then you guys can get started on skill sheets 1 and 2. Nice job, and get to work.